All right, I'm here with Alex Stone and the AI racing team, which is made up of the University of Hawaii at Maui, UCSD, and the Triton AI team. So Alex, can you start by telling us a little bit about how you guys have set up the team and some of the team roles?
So the team setup kind of came naturally. We were a small class. We were just doing basic little robotics, autonomous robots, and it mainly comprised of mechanical and some programmer engineers, but that's kind of where we lacked, and that's where UC San Diego really came in handy. Was after a few simulation competitions we had, they didn't have the assets we did, so we decided to come together and pull our strengths and really come through. You know?
Nice. And so what's been the most difficult challenge this season in terms of the development of the autonomous racing algorithm, which has been, I understand, part of the difficulty of making these things go?
Yeah, so you know, in the simulation, it truly is just a simulator. They can be, there's a lot of differences between the real world and what happens in that sim. And you know, the test can go good all day and we can solve a lot of our issues, or it can be done very early on when there's a simple problem as a sign flip, where we turn the autonomous stack on and we go, okay, it's gonna go right, and the wheels turn left.
Oh.
And so, you know, you gotta break it down, stop, and try to figure out what just happened and what the difference is from the sim and the real world.
So how did you learn to think like a race car driver?
So really the team has to give hats off to Gary. So in his younger years, he's actually a semi-professional race car driver. Wow. So that has truly molded our algorithms to be around some real world examples of how a race car acts. And what I think it puts us on a little bit of an edge compared to the other teams of having that experience.
So you've been able to extract his experience as a race car driver and to implement that in the code in terms of how to get the fastest path around the course.
Correct, yes.
So here's a good question. What are you going to tell your kids years from now about what the takeaway from this adventure in autonomous racing?
Well, from my personal experience, it's to say yes to scary things and get out of your comfort zone. This has truly been, you know, starting at little robots, we've made an autonomous go-kart, but nothing truly comes to the power and speed of an Indy Lights car, and that's going to be one of the main takeaways.
So how closely have the race simulations married or matched what happens in the real world? Because I think the simulation was a big part of this event leading up to the physical race.
So yeah, so within the simulator, there's a lot of configuration parameters you can set to try to match it to the real world.
Okay.
And so it's a constant battle of seeing what the car did with our algorithm in the simulator, what it truly did on track day, and then taking those two and try to mimic the simulator to have more of a real life feel. So it's going back and forth, go back to the simulator, test it, see if it mimics the real world.
And you guys were able to take your raw stack in the simulation and the same code is what's running back here in the vehicle.
Correct, yeah.
Right? Yeah.
We're running the same stack in both.
That's amazing that actually can do those sort of things. And so, give me your honest opinion. Do you think that the state of autonomy and autonomous vehicles, we keep talking about level 4, level 5 autonomy, out here in the real world and the streets behind us, not this street, but the streets outside of this. What's your feeling now after being so deep in this? Are we ready for that, or how long do you think it's going to take before we get there?
So I think we're very, very close, especially after the things that are being proven in this competition. Speed, there's a lot of parameters that don't occur in the real world, but this pushes those parameters to the extreme when it comes to detection and safety. And because we're realistically a year or two away with this test and pushing the boundaries with this car to fully understanding how to be a level 5 autonomous world.
Wow, so this event's really helping to push that envelope of technology forward in terms of advancing what has to happen to get us closer to that reality.
Right, because there's a lot of variables that occur in this race car that you can't test on a normal road.
Yeah.
You know, there's too many safety concerns, and if we can iron those details out here, that can make the autonomous system in our world that much more safer.
Right. So last question, and other than the weather that we're experiencing today, and hopefully we get some nice weather tomorrow, what advice do you have for the organizers about how to make this a more productive event next time around?
Well, they've done a great job so far. They have phenomenal support.
Yeah.
The only thing that I'd touch on is, you know, these things would probably take a little more track days.
Okay.
And that's always not any fault of their own, but track days were super valuable and super important.
Right.
And at the end of the day, it's real world testing that gets these things built.
I guess the good news is the vehicles are built now, so the next time that we do this, the vehicles are ready to go.
Yep, yeah, they're here and it's real.
All right, well, I want to say thanks for your time and good luck tomorrow, and
Thank you.
I'm looking forward to seeing everybody on the race course tomorrow.
Me too, thank you.
Thanks.